Who are we recording for? Aubrey and Brady and Owen. Yep. Okay. 9-5. This is trigonometry. Okay. And I just said that this was right triangle trig. So over here in the corner or wherever you can find a place, here's what I want you to write. This is something that you're going to have memorized in your noggin, and it is SOHCAHTOA. So S, little o, little h, C, little a, little h, and T, little o, little a. Write that down in a corner or somewhere where you can find him. SOHCAHTOA. What? I don't care. I want you to write it. Okay? Because we're going to write other stuff. Okay? SOHCAHTOA. That's something you're going to have memorized in your noggin before, whether you like it or not. Okay, S, the C, and the T are big letters. They stand for sine, cosine, and tangent. No, that's how you spell sine. Okay? In your calculator, it will be abbreviated SIN. You do not call it sin, you still call it sine. In your calculator, this will be abbreviated COS. You still call it cosine, you don't call it cos, okay? In your calculator, this will be abbreviated TAN. You don't call it tan, you still call it tangent, okay? So even though it's abbreviated with the 3 letters, still please call it by its whole name. Got it?
You called it tan over there. Tan lines.
Right. Yeah, that was a joke. We learned this last. Yes, we did. Awesome. Okay, what does O stand for?
Opposite.
Opposites, okay? So opposite here and opposite here, right? H stands for?
Hypotenuse.
Hypotenuse. So hypotenuse here and hypotenuse here. What does A stand for? Adjacent and adjacent. Adjacent and adjacent. Okay, so right below that, if you have any room at all, I'm going to have you draw this little triangle right here. Okay? And we're going to put a right angle right there.
How many degrees
Okay?
is the right angle?
And
Good.
let's pick this to be a special right triangle. So let's label some sides. Let's call them a 3, 4, 5. So let's put 3 here, let's put 4 here, let's put 5 there, right? And let's say angle X, because we have to have an angle to pick on. We have to be picking on an angle. So we can either pick on this angle or we can pick on this one. I'm going to pick on the bottom left angle. So call him angle X right there, right? Angle X. Okay? And this is how this works. Ready?
Well, we have to find how long the sides are.
Yes, we use sine, cosine, and tangent to find a missing side. Okay, but we'll get to that, right? So, because I'm going to show you how to make the ratios first. Okay, so first we have sine of X, and then we have cosine of X, and we have tangent of X, right? Okay, I'm just giving you this as an example. When you do sine, cosine, and tangent, you're picking on the angle. I gave you the angle as X, right? Sine, cosine, tangent of X, okay? We're writing sine as a fraction. And the parts of the fraction that go here, there's a top and a bottom, are these two parts, O and H, all right? So we've got to decide if X is the angle that I'm picking on. Are you listening? If X is the angle that I'm picking on, which side is opposite angle X? 3. So I'm going to label 3 as the opposite, right? Which one is the hypotenuse side? 5. The 5. So I'm going to label him with an H, and then that means 4 has to be adjacent. Do you know what the word adjacent means? Right next to. Technically, X has 2 sides that are right next to him. But 5 is the hypotenuse, which trumps adjacent, right? Okay? So we have O, A, and H. All right, so if sine, I'm going right here. Whoop. Sine is OH, so SOH. O goes on top, H goes on bottom. So the opposite side is 3. The hypotenuse side is 5, so sine of X is 3/5. Do you see how that works? Okay? Cosine is AH. Okay? The adjacent side is 4. The hypotenuse side is 5. So cosine of X is 4/5. Yeah? The tangent side is OA. What's that one look like? 3 over 4. And there it is. Tangent is 3/4. Yeah? Okay? So we're making ratios. Now, we're not solving for anything yet. We will eventually solve for angles and sides. Okay, we'll get to that. All right? But are we clear so far? SOHCAHTOA, how it works? It makes ratios of the sides, right? All right, so here we go. Let's go to example 1. Let's go to example 1. They have you do this in your homework assignment. And here's what we've got going on here. Okay, I have 2 different angles that I could pick on. Technically, there are 3 angles on this triangle, but you never pick on the 90-degree angle. We always either pick on K or we pick on J. Now, here's the deal. they are picking on J first. So they want to know sine of J, cosine of J, tangent of J. Got it? So if we pick on J first, and we look at these, J is over here. Shh. Which side is the opposite side of J? 5 is opposite. Adjacent is 12, and the hypotenuse side is 13, right? Okay, so when they do sine, sine is opposite over hypotenuse. They did 5 over 13, okay? They want us to also find what that value is as a decimal. Does somebody have 5 over 13 for me?
Probably about 0.37.
0.384. You're pretty close. Okay, all right, next, cosine. Which one is cosine? Cosine is AH, right? So adjacent hypotenuse, that would be 12 over 13. What's that? 0.923. Perfect. And the last one is TOA, T-O-A. O is 5, A is 12, so 5 over 12 is? 417, right? 417, okay? All right, now, here's the deal, real quick. If we then change to looking at angle K, what switches? The O and the A. The hypotenuse stays the hypotenuse, but now this is not the adjacent side. Now this is opposite, and this is adjacent, right? So here's the deal. If we look at this, the way that this works is that when you're looking at your two angles, sine over here will be the same thing as cosine over here. Sine over here will be the same thing as cosine over there. These two should just switch places with each other. Do you see how that works? Right? So you got kind of the answer. Now, tangent, what happens to him? He flips it, right? 12 over 5. Okay, so this is 0.923. This is 0.384. And this guy is 12 over 5, which is what? 2.4? Okay, there you go. Okay, so do you see the relationship? Because the opposite and adjacent flip places with each other, the sine and cosine are going to switch, right? All right, now let's use that to use a special right triangle to express the sine of 60 degrees as a fraction and a decimal. All right, so this is a 30, 60, 90. What are the sides? 1. Which side is your 1 side? The bottom. Which side is your 2 side? The hypotenuse. Then the square root of 3 side is over here. Okay, they want sine of 60. So which angle are we picking on? The bottom left, right? I want to know what sine of 60 degrees is, okay? Sine is S-O-H, right? Opposite is the square root of 3. And the hypotenuse side is? 2. Sine of 60 degrees is the square root of 3 over 2. You know what the fancy thing is? If you go to your calculator, as long as you are in degree measure, which you don't know what that is anymore, or is yet, you have to be in degrees and not radians. You don't know what a radian is, but you will. You do?
Turn up the radians, Wyatt.
Kind of, yeah. Okay, radians have to do with circles. Yeah. You'll know that a little bit more in trig, right? Okay, so sine of 60 degrees, if you type that into your calculator, it will give you the square root of 3 over 2, probably as a decimal, right? Okay, it won't spit out exactly square root of 3 over 2, but it should give you the decimal form of square root of 3 over 2.
Mine spit out that because I'm smart.
That's nice, okay? That's just the setting that your calculator's in, okay? So they ask for what is sine of 60 degrees as a fraction and a decimal. What's the decimal?
0.866.
0.866. There you go. So fraction and decimal, sine of 60 degrees. That's using that special right triangle to find that, okay? All right, here we go. Now let's actually solve for something. Ready? Let's actually find something. Shh. Okay. It's hard for me to see that a little bit, so I'm going to go down, I'm going to go down over here, and I'm going to draw a triangle. So do that over here in this corner. They call this Y, they call this X. My 90-degree angle is here. They say the ramp is 12 feet, and the angle is 4 degrees. That's a really small degree measure, okay? All right, so we're going to actually use sine, cosine, and tangent to solve something. Turn around.
Can I put my water on?
No, just wait. 4 degrees. There you go. The angle that we're picking on is the 4-degree angle. You got to listen. Shh. Shh. 4 degrees. Okay. Do you want to solve X or Y first? Which one?
Y.
X.
Y.
Let's do X. I heard them say X. Okay. X. So I'm going to circle X. I have to use one other piece of information, and the only other piece of information I know is 12. Okay. So here's the deal. Listen. We have to decide whether we're using sine,
It's tan.
cosine, or tangent, right?
Tan.
No, it's not tangent. It's not.
You're not good.
4 degrees is here. So, if I'm looking at this, what is x in relationship to 4?
Jason.
He's the adjacent side. What's 12? Hypotenuse. Which one uses a and h? Cosine. All right, so here's how I set this up. Are you watching? This is how you solve. Cosine. I'm going to do cosine of something. 4 goes in the cosine. Equals
Don't read that.
a and then h, right? So x goes on the top and hypotenuse goes on the bottom, and that's 12. All right, now, last thing. How do I solve for x? How do I get x by itself? I'm going to multiply 12 over. Get your calculator out. Type in 12 times cosine of 4. Do that.
11 point. 12.
Whoa.
Yeah,
What is it?
just 12.
No, go 11 point something.
11.97. 11.97.
11.97. We can't say 12 exactly because then that'll be the same thing.
Yeah.
I don't care. We can't say 12.
Why can't
Do
you say
12.0 with the bar over.
No,
That's not
no,
the same thing.
no, no, no,
Why
no.
can't?
11.97. Okay.
Hey, can you stop?
All right, now we have y. We got to solve for y. We still got to use our 4 degrees, and we got to use 12 right here. Okay, so I'm looking at the purple ones, right? What is y in relationship to 4?
Time's always boyfriend.
Opposite.
Opposite. What's 12? Hypotenuse. Which one uses o and h?
I'm next.
O and h. Sine. Okay, so now we're going to set up a sine function. Sine of what? What goes inside of sine? 4 equals, opposite is y over 12. Okay, how do I solve for y? How do I get y by itself? Multiply by 12, multiply by 12. 12 times sine of 4. Boys, you have got to be listening.
0.837.
0.84,
Do you have a fancy one?
whatever. 837, whatever. Your calculator's in radians, I bet. Does it say R at the top or does it say D?
It doesn't say nothing.
Go to
Oh, it
mode.
does say reading.
Hit the, it does hit, go to mode. Okay, all right. You're fixing it for it. Okay, there you go. Those are my two sides, 11.97 and 0.837 or 84, whatever, right? That's how you solve those guys. Thank you, sir.
Good one.
Okay?
Yes, Tina.
All right, go to, nope, go to this guy, example 4. Go straight to example 4. Okay, shh. Go straight to example 4. If I see one more thing fly across this room, the person who throws it and the person who receives it is having detention. I'm done. No more. No, no, no more. Okay, example 4. They want us to find the measure of angle A. I don't know what the angle is this time, so I'm going to call it X. Put an X right there in that corner. We're on example 4. Go. X is there. All right. The two sides that it gives me are 15 and 3. What is 3 in relationship to X? Adjacent, so put an A there. What's 15? Hypotenuse. So SOHCAHTOA, right? Okay, we're going to use cosine. Okay, cosine of, when we set this up, what do we put inside of the cosine? X, that's what we're trying to solve for, right? Okay, now put your hand down. Cosine is A over H. So 3 over 15 goes here. Now here's the deal. If X is what we're solving for, how do I get rid of cosine? You can't divide by cosine.
Opposite of cosine?
You do the opposite of cosine, which is this guy. You see that button in your calculator? It's like the shift cosine, right? So if we do that to both sides, it crosses it off here, and X is the inverse cosine of 3 over 15, right? Okay? And you should get how much?
Kind of a crazy number.
What'd you get?
78.
Okay, that's what I got.
78.5 degrees. Okay?
Why is that a crazy number?
That's not a bad number. 78.5 degrees, right? That's the angle, right? 78.5. Okay, then what would this angle down here be? 11.5, right? Degrees. This is a short side, this is a long side. So that should make sense, right? 78.5 and 11.5. Do you see that, how that works? Yes, sir, Trevin.
You did not do that right.
What?
What if the hypotenuse is also the opposite?
It won't be because we never pick on the 90-degree angle. Does that make sense? That was a good question. What?
What if we do pick on the 90 degree?
You won't pick on the 90-degree angle.
It's
Ever. It has to be the two acute angles that you're solving for. Okay?
Cosine of 90 is like a circle.
Cosine of 90 is 0. Sine of 90 is 1.
Yeah.
So,
X.
yeah.
Yeah.
What? Tangent of 90 is
I still have my
undefined.
pink sheet.
It doesn't have an answer. Okay? All right, let's go. Oh my heavens. Example 5, last one.
Oh my.
Example 5. This is the hard one. Ready? Listen to this one. Here we go. Solve the right triangle. Shh, you got to listen. I'm going to kick people out. Solve the right triangle. Example 5. These are the ones that are kind of icky because when it says solve, it means find everything. Find all of the things. And here's how I want you to write this. I know I have 3 angles. They are angle R. They are angle S, and they are angle T. Got it? The sides, though, I could call this side RT, right? Or I could call it something else. He is called little s. He is called little s. Why is he called
Opposite
little
from
s?
The angle S.
He's opposite from angle S, right? Okay? So, that's little s, okay? What is this side called?
Little R.
He is little r, right? And then this side is called
Trevin.
little t. All right, so here we go.
Yeah, that's not-
So I have to solve all 6 things. Some of them I already know. I already know 3 pieces of information. What is 9?
Little S.
9 is little s, yeah? What is 6?
Little R.
6 is little r. What else do I know?
Angle.
Angle S is 90 degrees. All right, perfect. Those are the 3 things that I know, yeah? Okay.
I see something.
What should we do?
Solve for little t.
You want to solve for little t? How do you want to solve for little t?
So,
You could use sine, cosine, and tangent, or
a triple.
it's not a triple. It's not a triple. Pythagorean theorem, right? Okay. Which side is side C? Which side is side A? Doesn't matter. Let's call this guy A. Let's call this guy B. So A squared plus 6 squared equals 9 squared. A squared plus 36 equals 81. If I subtract the 36, you said 45?
I think Clayton.
45 equals A squared. Take the square root. What's the square root of 45?
6.71.
That is little d. 6.71? Yes, perfect. Okay, now we have to do something else to solve for R or S or R or T. Which one do you want to pick on first?
R.
I shouldn't erase that. I don't need to erase that. Let's do R?
Gotta
Sure.
pick on T.
Okay, now I know. Here's the deal. Let me teach you some things. 6.71 is this guy. Okay, I have all 3 sides, right?
Use the ones you get.
I can use any of those 3 sides to do sine, cosine, and tangent. I only need 2 of them. Which 2 are you going to use?
They give you a case.
Technically, I could use this one, but I don't want to because I rounded that number, right? I want to use the 2 that they gave me. It didn't matter. It didn't matter, right? R, what is 6 in relationship to R? Opposite, what's 9? Hypotenuse. So we have SOHCAHTOA. We're going to use sine because those are the 2 that we have, all right? So I'm going to set this up. Sine of what? R. Sine of R is equal to, opposite goes first and then hypotenuse. 6 over 9. So how do I get R by itself? I do the inverse sine. So inverse sine of 6 over 9. R equals what? 41.8 degrees is what R is. All right, 41.8 degrees is here. Now, you could go through and do a different trig function to solve for T, or these 3 angles should add up to be 180. Or this angle and this angle should add up to be 90. So it is 40 what? 48.2. Okay, real quick. One last thing. And this is a good eliminator. Do you see this? Which side is my largest side? 9. Is it opposite the largest angle? Which side is my smallest side? Is it opposite the smallest angle? That should check out every single time, okay? So, these ones where it says solve the right triangle, you have to solve for all the angles and all the sides just like we did there. They will give you 3 pieces of information already, but you have to solve for the remaining ones. Got it? Okay? All right, homework.
12.
Page 537.
1 through 13 odds.
I don't think so. Trigonometry, page 537. 4 through 20 evens.
What? 4 through 20.
And number 24.
Cometra,
I
I
think.
won't be here tomorrow.
Wait, what is this?
Shut
Number
up, fat.
4 through 20.
Hey,
evens, and
no.
then 24.
No. No.
I won't be.
No. I don't care. That's fine. 4 through 20 evens and 24.
But that's not fine. I'm gonna listen.
We skipped 14.
Shouldn't care about your mental health, Wyatt.